All right, now in the actual, this is part two of the column chromatography video. Um, what we're going to be doing is first thing you have to do is get your column prepped. And when you watch the video, they'll show you how to do that. But essentially, what you're going to do is the easiest way to do it is to get get some of the Brockman adsorbent, and what you're going to try to do is get that into the column. And there's several methods. And the best method I've ever found really is, and you have to be kind of careful with it, but make sure you got a funnel. Take your column, such as this, you just got a plastic funnel up here. And you're going to make a slurry of hexane, which is going to be one of the solvents that we push things through with, and your Brockman alumina. And what you'll do is just pour that into the column. And the solvent will go through the frit, but the Brockman aluminum oxide will stay behind. And you'll see the liquid start to fall through that. And you want to have more solvent than you do um, aluminum oxide, because you don't want the aluminum oxide to ever get dry. That's going to be your most difficult part. Then you can come back in. So have the valve off at that point. I would not have it on at that point. And then you're going to let everything settle down nicely. You may have to tap it a little bit on the sides if you see some bad areas. And there are times when you just have to blow the whole thing back out and reload it. So you want to be kind of careful. Don't just dump it all in there, but try to pour the slurry in. So you have to kind of suspend it because it's all going to want to sink. Pour that in there, let that build up to your 15 centimeters. And then you go grab a little bit of sand, and you'll take the sand and throw in the sand over the top of it, so then you've got it ready. You can drain out a little solvent at that point, and then you'll be ready to go. So when we extract the tomato paste, we're going to do that in the kind of a series of steps. And with that in mind, you want to get about somewhere in the ballpark of, I don't know, maybe 4 grams or so of tomato paste. You may even want to go 5 grams. It says 4, but I'd probably be pretty happy with 4 to 5 grams of tomato paste. And then with that, real simply, what you're going to do is you're going to do 3 times. You're going to do 10 milliliter portions, 3 extractions, and it's a 50-50 acetone petroleum ether mixture. Now, each time when you do this, you want to filter the extract through fluted filter paper into like an Erlenmeyer flask. After every time that you do the extraction, decant the liquid onto the filter and then press the residue. You'll see how they press the residue in the video with a flat, and the method that they use is a little bit different than we use, where they the first part of the video, you don't want to watch how they do their extraction, because their extraction is a different methodology than we're going to use. They use a method where they get rid of everything else that's in the material, and then they take the tomato paste is left over and go ahead and use it to get it out of. So follow the directions in our book. So filter the extract through the filter paper. After each one, decant the liquid onto the filter, and then press the residue that's left in the beaker with your spatula and squeeze out as much liquid as you can. After the third extraction, transfer the residue to the filter. And then what you're going to want to do is wash it with 5 milliliters of the extraction solvent again, and combine that liquid with the with the other extracts. So in essence, you're really going to kind of do it 4 times. You're going to do 3 extractions of the tomato paste, combine all those extracts, and then put the residue one more time um, with the extraction solvent one more time. Put the residue right into the filter paper on the last one. And a lot of times, if you want to, and you'll see it in many places, that they'll mash it on the filter paper the last time to see if you can pull out any more, and that will give you a little bit. So if you use 5 and you're not so careful, you're probably still going to end up with a good amount of lycopene. So then after you've done that, you're going to wash it with 20 milliliters of 10% potassium carbonate. This is a base, so this will get rid of acids that can degrade the lycopene. They change the isomerization. Then you're going to use 20 milliliters of salt solution, saturated. What does this do? Here's a good final exam question. What this does is, very simply, this is ionic, right? Well, that ionic is going to dissolve in the water layer. What that does is make the H2O layer more polar. Lycopene is very nonpolar, so we want it to go into that petroleum ether layer. And we get a double bonus. The fact that we have water in there, acetone dissolves in water. So really, the acetone is going to go with the water. And now we'll just have the petroleum ether. And our thought process there is, when we do this extraction, is that now that lycopene is going to migrate to this layer, and nothing's going to want to go to this almost ionic layer, a liquid ionic solution. Then what you'll do is dry it. The organic layer. Dry the organic layer. And you have saved the organic layer. We did not talk about, make sure you look up the densities of these two, of which layer you should be keeping. So be careful on that. Dry the organic layer with MgSO4. And then what you're going to do, without heating, you're going to use air to evaporate down to about a half a milliliter. The good news is, if you go too far, you can always add back, maybe 10 drops of hexane. If you inadvertently get it to dryness. So if dry, add about half a milliliter, around 10 drops from a dropper. Those little droppers in the box in your drawer, the black bulb on the kind of fat droppers of hexane to reconstitute. So then, what you'll do at that point is, there's a series of materials you have to run through the column. And the key on that is, when you watch the video, is don't ever let the liquids get below the sand layer. So typically what I tell you to do is, when you see that liquid just move below the sand layer, that's when you want to stop it. So I'm going to have to go to part 3, and we will finish her up with that.